did it come to this. I guess I just need to take you back to the start of this whole mess. But I have to warn you now, this video is a tragedy. If you're looking for one of those hunky-dory videos where parts come out perfectly on the first try, well, I suggest you try a Ron Covell video. But if you're in the mood for a hearty chuckle and the warm feeling that comes when you think to yourself, I'm glad I'm not this guy, well, this is the video for you. If you're just joining me, my name is Steven, and I'm a cinematographer with an unhealthy interest in engineering and robotics. In my last few videos, I've been working on a robot arm that'll hopefully carry a camera and help me get amazing shots. But for this video, I'm taking a break from machining to explore a material that brings out the inner child in me. That's right, carbon fiber. Yeah, we're going back to the future like it's 1990. Now there comes a time in every maker's journey where they stumble across a video by a company called Composites. And you've probably seen a few of those videos. Flawless carbon fiber parts made with simple tools and just a little bit of elbow grease. So easy, even you can do it at home. Watch a video or two, and you'll quickly feel like an expert. How to vacuum bag? Check. What's the layup stack look like? No problem. Well, kids, spoiler alert, there's nothing easy in this video. But with my Dunning-Kruger gauge all topped up, I decided to just jump right in on my first part. My first part is a cover for the wrist joint on the robot. The tricky bit about this part is that the fit on the inside is fairly unforgiving. And normally you would just mold the inside of the part, slap some carbon fiber on it, and if you're feeling frisky, pop it in a vacuum bag. But I wanted a really nice surface finish on the outside of the part too. So I decided to try a 2-part compression mold. And if you have any experience with composites, you'll know that this mold is terrible. Basically, mold design is all about figuring out how you're going to release your part from the mold. And you usually accomplish this by adding a slight angle to vertical walls, a draft angle, that reduces the friction as you slide it out of the mold. The problem is that this cover has to mate to already existing parts, and I didn't design those parts with a draft angle. So this mold has no easy way for the part to release. So anticipating this, I designed this mold to have some compliance. Basically, the idea was to laminate the outer mold with several layers of carbon, jam the inner mold in, then jam a stiffening insert into that. A bunch of clamps and pressure should take care of the rest. Perfect part on the first try. What could possibly go wrong? So I figured I should just dive right in and printed out the mold parts. To smooth out the layer lines, I slathered a bunch of coating epoxy all over my mold surfaces. And then came time for sanding. Lots and lots of sanding. I really dislike sanding. I know some people find it zen. I don't. After working my way through the grits, it was time for a very half-hearted attempt at polishing. And then many coats of mold release. Then it was time for the layup, which first involved coating the mold in epoxy, then laying a sheet of fiber, and then continuing through the layers. Things were starting off well enough, so I'm using Total Boat 2:1 medium epoxy, and my pot life should have been about 25 minutes. However, my shop that day was a steamy 92 degrees Fahrenheit. So about now you can see my panic as I realize about 10 minutes in that this pot is starting to go off. In hindsight, at this point I really should have just mixed a new batch of resin and then calmly continued laminating. But that's not what I did. No, I did the braver thing. I worked faster and more sloppily. Here I'm just pouring the epoxy into the mold and slapping layers down as fast as possible. The epoxy is quickly turning into a sticky tar that is far more interested in adhering the carbon to my brush than to the previous layers. So it's now or never. The second part of the mold has to go in. To improve my odds, I used some release film on the last layer of carbon to hopefully protect it as I inserted the plug. So let's see how this went. And look at that idiot. So after as much disaster mitigation as possible, I did manage to get the second part of the mold in and clamped the whole thing up. And when it came time for the demold, man, it really put up a fight and totally destroyed a good chunk of my mold on the way out. So yeah, the outside of the part is surprisingly smooth, especially when you consider how incredibly messed up the weave of the carbon is. It's the inside that's awful. One side is significantly thicker than the other. And carbon obviously just got randomly shoved every which way as I inserted the second part of the mold. I guess technically this could work as is, so I decided to cut away the extra carbon and finish off the edges. But I'd really like to revisit this part, and probably give it a complete redesign. But maybe later. So let's move on to our second disaster. Yeah, it's gonna be that kind of video. So I figured I'd learned a few lessons, and it was time to move on to a more complicated part. Cause that's what you do when you fail at the simple one. The forearm of the robot needs 2 side covers to protect the pulleys and belts. Now if these are just covers, why bother with carbon fiber? Well, these covers actually provide an opportunity for some big gains in strength and stiffness, without much, if any, weight penalty. Now disclaimer, I've said it before and I'll say it again, I am not an engineer. But with that said, here's my idea for how this should work. If I make the side covers stiff and strong, and then rigidly attach them to the forearm side plates, then they actually become stressed members. Think of it like a monocoque chassis in a car, or an egg. We can actually use the skin of the structure to increase the overall strength, stiffness, and resistance to bending. The forearm is essentially a box structure. By adding these stressed members, we also essentially increase the diameter of the arm, which also helps with that whole resistance to bending. Alright, so this all sounds good, but how do you make the side cover stiff and strong? Well, there are a few ways. One is to add thickness in the form of carbon fiber layers. But another thing we can do is add a bend or two to the structure. Again, just like that egg, having some curvature really helps add strength to a thin-walled structure. So, I designed up a mold. After sanding and prepping the mold, I got to applying the mold release. I'm going with a few wax coats and PVA. The temperature is 80 some odd degrees, so I haven't really learned anything about not doing composites in the heat. And yeah, my camera totally ran out of media right as I was getting started. Amateur. But here's a quick summary of what went down. The carbon fiber did not want to conform to the tight curves I'd designed for the bolt attachments. The epoxy started to kick again because heat. The PVA started to lift off the mold because the epoxy got sticky. And I gave up soon after that, since it was obvious that my mold design was way too difficult to laminate. Okay, maybe hand layups just aren't my jam. So I'm going to try my hand at some resin infusion, and hopefully this takes some of the stress off when it comes to dealing with the short pot life. So it was time for Mold 2.0. This time redesigned to make the curve simpler so that the carbon fiber could conform to the mold. And I added a decent sized flange to allow us to attach the bag for the infusion. So I assembled and coated the mold. Much sanding and polishing later, and I was pretty pleased with the results. And hopefully after coating, it would be vacuum tight. Hopefully. So I trimmed up a bunch of layers of carbon fiber and started prepping the stack of materials. If you're not familiar, here's a rough idea of how resin infusion works. You attach sealant tape directly to the flange of your mold, and then you position all the dry layers, along with a few helper materials. The spiral tubing creates a channel for the resin to flow down the length of the part. The mesh facilitates the flow of resin through the part itself. Once everything is properly placed, you seal the mold with a bagging film. You feed 2 hoses through the bag, the resin inlet and the vacuum line. Once everything is prepared, you turn on the vacuum pump and use vacuum to hold the fibers against the mold and to pull resin through the part. So this takes a lot of the time stress out of the equation, since you have infinite time to get all the layers perfectly positioned in the mold. Plus, it helps you get closer to that ideal resin to fiber ratio. Now they make special resin designed specifically for infusion. It's got a lower viscosity and usually a longer pot life. It's also expensive, so I'm just using the laminating epoxy I already have. I mean, how different could it really be? So it turns out that the main thing you have to get right about resin infusion is literally everything. You just kinda have to do it perfectly. So here's attempt number 1 in action, and it started out okay. And now we're about to watch everything spiral out of control. It started with some bubbles running through the part. This was an indication of a leak. Okay, maybe a couple of leaks. So I paused the infusion for a moment by clamping the resin feed line, and did my best to seal the, let's be honest, numerous leaks. And then I reopened the taps to allow the resin to flow again. But nothing seemed to be flowing. The resin had already reached the vacuum line and started to plug it up. So vacuum was no longer getting to the part. I did my best to mitigate this, and got some more resin to flow through the part. But it was about then that my pot of resin began to smoke. So yeah, this infusion is over. Turns out it was a really bad idea to pause the process when the resin is just begging to flash cure in the heat. It really takes me a long time to learn some lessons. It looks like the resin might have at least covered the outline of the part, so I had some hopes that it might be okay. But after demolding, it was pretty quickly obvious that this part was a failure. The resin had only infused through half of the part, and honestly the parts that had infused weren't nearly as stiff as I was hoping they would be. So it was time to try again. This time I added a few more layers of carbon to the stack, and I was very careful when sealing the bag around the edges. However, no matter what I did, the part wouldn't hold vacuum for long periods of time. The leaks were catastrophic, so I decided to cut my losses and rebag the part again. This sucks, but if it saves me time from having to chase down a bunch of leaks, it's probably worth it, and are you kidding me, it still won't hold vacuum. It was somewhere around here that I realized that some of the leaks were coming from microscopic punctures in the bag itself. The material was quite old, and maybe not the thickest bagging material out there, so I went crazy applying sealant tape to any suspected leak until it seemed to be holding vacuum well enough. And so it was time to try again. And yeah, with that same resin. But in my defense, it was a much cooler day, and I wasn't planning on stopping the infusion this time. So I mixed a big batch of resin and started the infusion, and then quickly did my best to patch up the leaks that I had somehow missed. And the part actually looked like it infused okay. The resin appeared to flow from one end to the other as intended, so I had high hopes when I went to demold the part. Hopes that were very quickly dashed when I saw that the resin had failed to infuse all the way down through the layers. It had traveled across the part as planned, but I think the epoxy was just too thick to soak through 7 layers of carbon. Okay, here we go with lucky number 3. I bought thicker bagging film. I bought long pot life infusion epoxy. And yes, it's pricey, but not as pricey as 2 ruined carbon fiber parts. So yes, the details and the right materials really do matter. I was beginning to suspect that my mold might have microscopic holes in the coating layer, so I poured over it carefully and covered any suspected holes with flash release tape. I cleaned and prepped the mold thoroughly. I got my work surface as clean as I possibly could. I got my materials ready and prepped the bag. And then a new video from Easy Composites miraculously appeared in my feed, and it was all about resin infusion. So here we go, it's a sign, baby. I adjusted my strategy for the vacuum and feed spiral. I made sure to add a good resin break to ensure the vacuum line didn't clog up. I was meticulous in sealing the joints for the feed and vacuum lines. And you know what? It totally failed once again. So I went back over every millimeter of tape. I massaged every joint, and I prayed to the gods of composites to finally grant me success. And this time, it looked okay. So I mixed up the epoxy and got to infusing. And wow, what a difference the infusion resin makes. It just goes through the part in no time. And the new strategy for the line placement seemed to work really well, as the whole part looked like it wet out super evenly. The only thing that worried me were all the bubbles that kept appearing in the vacuum line. I had expected bubbles as the resin first hit the line, but these bubbles just kept coming. So yeah, even after all that, there was probably still a leak. So I had mixed expectations when it finally came to demold the part, which by the way was a long time later. The downside of a long pot life is usually a really long cure time. So the part demolded fine, and holy crap, it actually looks okay. Not great, far from perfect. but maybe if you glance at it quickly enough, you might think it was a pretty good job. There are pinholes and surface defects, but the carbon wet out evenly. And most important, it's stiff and highly resistant to bending. Okay, so it took some time to get an acceptable part, but we did get there in the end. So what makes this video a tragedy? Well, if you remember, I need 2 of these parts. So I had taken a bit of a break after making the first part, and I stored the mold on top of my tool chest, near a window. My mold made from PLA plastic. And you might guess where this is going, but the sun is powerful. And this is the current state of the mold. So yeah, another ruined mold, and only one usable part. So at this point I have 2 options. I can reprint, coat, sand, polish, and go through that whole process again. Or I can make a fiberglass mold using my one good part as a master. And I think I'm probably gonna go with option 2, because I think that will be less work in the end. But yeah, I'm gonna be honest, this one kind of hurt. So what have I learned from all this? Well, for God's sakes, don't work on carbon fiber parts when your shop is hot. And get the right materials. And don't store your mold near a window. And watch all of Easy Composites videos, because they're actually great. I just can't follow directions. Composites can be easy, if you don't make them too difficult. And thanks so much for sticking with me. If you want to see more robot content, check out another video here. Please like, comment, subscribe, and ring the bell, and I'll see you on the next one.